All right, let's dive into something pretty wild today. We're looking at a fascinating paper that asks a question so basic it could literally change how we build AI. What if you could create a powerful artificial intelligence that can't multiply?
Do we really need multiplications in deep learning? Now, this isn't just some clever title. This is a direct challenge to one of the most fundamental assumptions in artificial intelligence. It's the kind of question that makes you stop and rethink everything you thought you knew.
You see, for years now, deep learning, especially these things called convolutional neural networks, or CNNs, which are the brains behind image recognition, has been built on a foundation of just millions and billions of multiplication operations.
But what if that very foundation is also its biggest weakness, its biggest bottleneck? This brings us to the core problem that these researchers set out to solve.
And here it is, straight from the paper itself. The authors point out a simple truth that has massive consequences. For a computer, multiplication is hard work. It's complex, it takes more time, and it consumes a ton of energy compared to simple, cheap addition.
So let's look at this matchup, right? In one corner, you've got multiplication. It's this slow, power-hungry titan of computing. And in the other corner, you have addition, the fast, efficient, lightweight challenger. In the world of computer chips, this difference isn't small, it is huge.
And we're not just talking about one or two calculations here. A modern AI model, just to process a single image, is performing an absolutely astronomical number of these expensive multiplications. It's like a massive computational traffic jam.
So, what's the way out? Well, the researchers didn't just point out the problem. They came up with a really radical solution.
They call it AdderNet. And the core idea is, well, it's brilliantly simple. They essentially said, what if we could just swap every single one of those costly multiplications for a lightning-fast addition? Imagine clearing that entire traffic jam by replacing every single truck with a bicycle. And I know what you're thinking. That's the obvious question, right? You can't just swap a times sign for a plus sign and expect it to work. They measure completely different things. Or do they? Now this is where it gets really clever. It's a fundamental shift in thinking. A traditional CNN uses multiplication to measure how similar a feature in an image is to a filter it's learned. A high score means a really good match. AdderNet just flips this on its head. It uses subtraction, which is just a form of addition, to calculate what's called the L1 norm. It's a fancy term for just adding up the absolute differences between the feature and the filter. So instead of a high score for a match, it gets a low score, a small distance. It's a shift from asking how much do these match to how far apart are these. Both get you to the same conclusion, but one does it way more efficiently.
But, of course, this brilliant idea came with its own set of really tough challenges. To make this new kind of network actually learn, the researchers had to do some pretty clever engineering.
The standard methods we use for training neural networks, like a process called back-propagation, are all built around the specific math of multiplication. So when you take that away, you pretty much have to throw the old rulebook right out the window.
So, the team had to innovate. First, since the old way of learning from mistakes wouldn't work, they had to design a completely custom backpropagation method just for this new addition-based math. Second, they found that the network's learning was a bit unstable, so they developed a really smart, adaptive learning rate. You can think of it like a system that automatically adjusts how big the learning steps are, preventing it from messing up. These two breakthroughs were the crucial keys to unlocking AdderNet's real potential.
So, after all of that incredibly hard work, did this radical idea actually pay off? Could an AI that only adds and subtracts really compete with one that multiplies?
This is the moment of truth. Because the ultimate test for any new network is how well it performs on a massive, real-world challenge, like the famous ImageNet dataset.
And the answer is a resounding yes. Using a well-known architecture called ResNet 50, the AdderNet version achieved an incredible 74.9% top-1 accuracy on ImageNet. Now, this is a highly competitive result, and it proves that this addition-only idea is not just some novelty, it is a serious contender.
And let's put that in perspective for a second. This table shows that AdderNet achieves performance that is right there in the same ballpark as standard multiplication-heavy networks. But just look at that last column. It gets there while using absolutely zero multiplications in its main layers. It completely sidesteps that computational bottleneck.
So, why is this such a big deal? Because it could open the door to a future of way more efficient AI.
We're talking about AI that uses way less power. We're talking about powerful AI that could run on smaller, everyday devices like your phone or a smart camera without completely draining the battery. It can make AI development faster, cheaper, and more accessible for everybody.
And that leaves us with one final big thought. AdderNet showed that one of the most basic, fundamental building blocks of AI wasn't as essential as we all thought. It really makes you wonder, what other core assumptions are we making right now that are just waiting for a brilliant new idea to come along and challenge them?